Welcome to Water Science for Everyone.
Imagine trying to predict how much water you could pump from a well, or how a drought might affect a local stream fed by groundwater. To make accurate predictions, we need to understand how water is stored and released from underground formations. Yes, storage coefficient and specific yield absolutely apply differently, because they describe distinct ways aquifers store and releases water, depending on whether the aquifer is confined or unconfined. Recognizing this difference is fundamental to comprehending groundwater systems and managing our water resources effectively. The core distinction lies in the physical mechanism of water releases. Storage coefficient, often called storativity and symbolized as S or S sub C, is a property primarily associated with confined aquifers. These are aquifers bounded above and below by relatively impermeable layers. When water is pumped from a confined aquifer, the water itself expands slightly, and the aquifer matrix compacts a tiny bit due to the reduction in pressure. This water released from storage comes from the elastic compression of the aquifer material and the expansion of the water. Because these changes are subtle, the storage coefficient is typically a very small, dimensionless value, ranging from around 1 times 10 to the negative 5 to 1 times 10 to the negative 3. On the other hand, specific yield, symbolized as S sub Y, is the crucial parameter for unconfined aquifers, also known as water table aquifers. In an unconfined aquifer, the upper boundary is the water table itself. When water is removed from an unconfined aquifer, gravity drainage is the dominant process. Water literally drains out of the pore spaces in the saturated zone above the declining water table. This is why specific yield represents the volume of water released from storage per unit surface area of aquifer per unit decline in the water table. It is a much larger dimensionless value compared to storage coefficient, typically ranging from 0.01 to 0.30, reflecting the substantial amount of water that can be gravity drained. So, how do hydrogeologists put this understanding into practice? When you are working with a confined aquifer and need to predict drawdown from a pumping well, you will use the storage coefficient in transient flow equations. This is critical for designing sustainable pumping strategies and understanding the regional impact of groundwater extraction. Conversely, if you are analyzing an unconfined aquifer, you would use specific yield to estimate how much groundwater recharge occurs, or to calculate the total volume of water stored in a particular area. It is also essential for modeling water table fluctuations and assessing the available water supply for irrigation or municipal use. Choosing the correct parameter is not just academic. It is vital for accurate hydrological models and the sustainable management of our hidden water supplies. An interesting insight is how these values highlight the efficiency of water releases. For a confined aquifer, the water released by elastic processes is relatively minor. However, for an unconfined aquifer, the specific yield closely approximates the effective porosity, which is the fraction of the total volume of rock or sediment that consists of interconnected pores capable of transmitting fluid. This means that specific yield directly tells us how much of the aquifer material is effectively contributing to water storage and releases through drainage. This distinction between water released from elastic properties versus gravity drainage is a cornerstone of quantitative hydrogeology. Ultimately, by understanding the distinct characteristics and applicability of storage coefficient and specific yield, we gain powerful tools to accurately characterize different types of aquifers. This precision allows us to develop more reliable groundwater models, make informed decisions regarding water availability, and implement effective strategies for managing groundwater contamination. It ensures we approach the challenges of water resource management with a deep scientific foundation, safeguarding our invaluable underground water reserves for the future.
If you love learning about water, like, subscribe, and keep exploring with us.